Okay, for all of you who is online, let me express my welcome to you. My name is Tien-Yin Chou. I'm the director of the GIS Research Center in Huang University. On behalf of Taiwan Space Union, welcome all of you to join the TSU GIS online course. This course is planned to from November 15 to December 27, but there will be only 6 classes. Each class lasts for about 2 hours every Wednesday from Taiwan time, 2 p.m. to 4 p.m. So you're welcome to join the course. Today, I'm going to talk about the smart city issue. My name is Tien-Yin Chou. I'm currently a professor and also the director of the GIS Research Center in Huang University in Taiwan. And also I've served as a president for the Taiwan Agriculture Information Technology Association and also the chair for Open Geospatial Consortium, Asia Forum, and also serve as a Secretary General as Asia Pacific Federation for Information Technology in Agriculture, which is called APFITA. So I had my bachelor and master program from National Zhongxin University in Taiwan by the Department of Soil and Water Conservation, and got my PhD in Michigan State University, Department of Resources Development. Let me express my welcome to you to join this GIS online course. You're welcome to submit or raise your hand during the lecture. So this lecture will last for about 50 minutes each. So we'll have 250 minutes. So totally will be 100 minutes for this afternoon. So today, I'm going to talk about the smart city with a digital twin solution. The reason to talk about that one is from the previous week, the last week, also on the Wednesday afternoon, I mentioned about what means by the GIS, why we need the kind of spatial information to express our environment and also to conserve all the resources and how we can use the GIS and remote sensing and GPS and some other facility or technology to enhance the solution of our daily life, or even for government to in charge of some of the government issues. So when we talk about the GIS, we need to mention about the smart city, because most of this kind of technology will be embedded in some of the operation in any provincial city government or even any kind of city government. So smart city is one of very, very important and hot issue in many countries in the world. And also the digital twin. Digital twins means everything will be able to express it and also make it analyzable using the 0 or 1, which means digital format to express the entire concept and everything. So the smart city concept, from the broader definition, is a kind of process. It's not a static outcome, but it's also increase the citizen engagement, hard infrastructure, social capital, digital technology, make city more reliable, resilient, and better able to respond to any kind of challenges. So this afternoon, I'm going to demonstrate to you how the kind of GIS we can use it in the smart city application toward a kind of digital twin issue. I'll use some of the example from Taiwan. And because Taiwan, there are 23 million people. We live in an area of 36,000 kilometers square. So the entire country size is not that large, but we have only about 1/4 of the land is we call flat land. So in Taiwan, there are lots of cities. There are lots of cities. And there are some urban, or we say rural places in the slopeland or some high mountain area. So most of the flat land are all cities. So Taiwan government focused on the smart city for many, many years. And the reason for that one is we understand the core values of the smart city is connected to everything. Someone say smart city, and there are also another saying say intelligent city. It's a digital kind of things to express the entire city environment. So we have to use better communication and lots of electronic things, and especially use the kind of wireless to get communicated with everything. So we use the Internet of Things. We say IoT. And also lots of things we have to be a kind of information. So there's instrumented, interconnected, and intelligent. That means the smart city. And that's also the core value. The core value of the smart city is connect to the network of everything by information and communication technology. And the connection is try to make good between and among or within people, process, data, and everything. The camera, the temperature, the air quality, everything. So the core value is to improve people's life and satisfy their needs. So that's a core value. So that's 100% fit for all the mayor or the decision maker, how you can serve a very good infrastructure and environment for the entire citizen. So the objectives of the smart city consists with step one is information integration. So I mentioned about how the GIS can collect all the data, how the GIS can make as a digital format and buy or use any kind of information. And step two is information application services, which means all the information has to be served as a kind of application. It can be used and very wisely used by different way to express the entire city. And also the step three is information analysis and decision making. So all the information regarding tourism, environmental monitor, transportation, the sustainable environment, disaster prevention, economy, everything. If we can through the cooperation, the sharing, decision making, then there can be a very good governance of the city. So that's the objectives of the smart city. So that's perfect fit for every mayor to claim his or her city as a smart city, because lots of things has to be connected. So the new vision of a smart city is regarding almost everything, not only the people, but also the alerting, the vehicle, the lots of things, the cloud, the gas, the petroleum, the air quality, everything. So in the city, inside the city, everything is regarding as the factors of the smart city. So you have to have, in the very beginning, you have to have all the information already being collected, all the historical information, everything. Just like the last week, I mentioned about what means by the GIS, what means by the remote sensing, what means by the GPS, or we say the GNSS. Because we know the location, we know the spatial information. If we know the temporal information, we can organize a lot of things, a lot of things. So the smart city. Why we say smart city? It's a human-centered approach to innovation. So that's why the Taiwan government is really focused on the smart city. Each city try to champion with lots of different cities in the world to compete with who is the smartest one, whose application is the best served to the people. So it's a driving economic success. If any city is a kind of intelligent city or smart city, not only for good disaster prevention, and also to keep a good health. Now the people are very focused on the health. So the smart city, all this kind of technology to fit the human needs, to solve the right problem, and to driving the economic success. So that's the mean by the smart city. One of the things of the smart city in Taiwan is a very common one, the camera, or we say the CCTV. The camera has been set up every corner in Taiwan. The reason for that is for lots of things. or disaster prevention, and also to reduce the crime rate. And also to get a lot of things, even for the speedy or some kind of traffic jam, or even to identify if there is a fire or bad air pollution. All those kind of things, we can use a very common CCTV or camera and have those camera embedded with several new high technology, such as edge computing. Every camera is smart by itself. It can calculate, can analyze, it can send the alert when needed. And then send information back to the people who need to take care of that, or who need to pay attention on that. And also, we can have very, very good AI technology. Nowadays in Taiwan, the AI technology is a good innovation regarding every field. We can use the AI embedded with the camera, and the AI can learn by itself. So it can learn this condition is called a traffic jam. This condition is called accident. This condition is called a building collapse. Once it learned about those kind of information, it can get good accuracy, and then sending all alert or anything necessary to anyone who is making the decision. So in Taiwan, the kind of CTV is one of the very basic things become a smart city. So there are lots of sensors, not only the camera, every people. We will carry our cell phone. Our cell phone also embedded with a kind of receiver. The receiver will be able to receive different kind of navigation satellite information, and also use the Wi-Fi or some other technology to calculate where the cell phone is, the exact location. There is some technology can get a very, very detailed information and in every second, or roughly like 5 or 10 meters accuracy. So that's enough for most of the things we need to do. So lots of sensor, platform service, Internet of Things, connect with all the facility, natural environment, and built environment. There are lots of sensors. So smart city technology stack the synchronized, which means all the sensor can send different kind of information, and sensor can talk to sensors. So by the kind of communication scale, like nowadays, the wireless technology, it has become from the Wi-Fi 6, the third generation of the communication, the 3G, the 4G, even the 5G. And some countries are starting to study about the 6G. And also there are lots of LoRa, there are lots of microwave, there are lots of different kind of NB-IoT, those kind of wireless technology. Use different kind of technology to transfer the information at the right time to the right person or right infrastructure or right sensors. So all those signals can be transmitted directly. Even use a cell phone. Nowadays, a cell phone is so common. So almost everyone carry a cell phone. And the cell phone is equipped with different kind of communication, the SIM card, the Wi-Fi, the NFL, lots of. And also most of the cell phone has a camera. And a camera can capture lots of images. So when we say the Internet of Things, like several years ago, we say about the facility, about the camera, the rain gauge, the lots of different kinds of sensors. But now, Internet of Things is also concerned with people to people, people to machine. That machine can be the cell phone, can be a PC, can be a camera, can be a temperature, can be any kind of sensors, or machine to machine. We say this sensor can dialogue, can communicate with the other sensors. because it's embedded with the AI technology. So it can respond, it can reply, and also it can double confirm if one sensor is malfunctioning or not. So nowadays, all the technology can serve as a very, very good things and use the kind of internet of everything, which means all the things, if you have some kind of communication facility, either use the wireless one or even use a cable, then that thing can transmit it, can transform lots of different kind of information to different machine or different people. So that's the use of the smart city. So the new perspectives of the smart city is the goal to propose a common terminology and approach to the smart city, and how well-known models and examples can help establish a useful framework of thinking about smart cities. So I'm going to use some of the application demonstration to you to demonstrate how the GIS, how the remote sensing, how the kind of GNSS, which means the location and temporal and the spatial information, can be used to express a smart city, and how the cities, the managers, can use these kind of things. For example, if we try to track a position for moving forward, then we need to apply lots of things. The technology transfer drives innovation. The content-based, the services to support many needs. Application are the primary tools, the primary focus one. So open data creates economic benefits, enable to become a smart city. Lots of information you have to share with each other. You cannot just have one camera recording all information, but it can never be shown to any other camera or anyone else because it's useless. So any city claimed to be a smart city, it always has an open data policy, which means lots of this kind of information has to be visible, has to put on the transparency. So the smart city design goal is to improve our urban environment regarding nature resources or even for the financial. Why? Because once all the data is being open, there are lots of things can be done. But when we say the open data, it doesn't mean you cannot charge. Some of the information or some of the data, you can charge at the service charge. So nowadays, there are lots of different kind of software, even hardware. They charge by service charge. They're not charged by itself, but charged by the service. How much of service you use, how many quantity you use, then you pay for that. So the smart city design goal is also to improve the reliability for the good infrastructure, because basically all the city you have to have a very good infrastructure. Not only the hardware, but also the software, and also the people, and provide lots of services. So for any city, if we claim to be a smart city, it has to satisfy lots of things. So I try to explain what a smart city is by those kind of contexts and definition, and also what's inside. And now I'll use some of the demonstration and some of the application technology, how we use the most current hot issue like the AR, the VR, Internet of Things, or even the drone in the urban area in Taiwan. How we can use those kind of technology, how we can very wisely use the GIS, the remote sensing images, the aerial photos, the drone photos, or other sensors, the camera, to create a smart city. In Taiwan, there's a national GIS strategist has been promoted for the past about 30 years. And for the recent year, it emphasized on the sharing, the open, and interoperability. And now we are working on the three-dimensional GIS and digital twins. So that's why in Taiwan, the national GIS strategies now is toward a digital twins, which means we use the kind of nationwide GIS services to reach the goal of a digital twins, to represent every smart city. So the development dimensions in Taiwan is the standardized. Why? Because every sensor has to talk in the same kind of languages. So the camera will be able to talk to the rain gauge. We're able to communicate with the temperature. Or your cell phone will be able to talk to others' cell phone using the same kind of language, using the same kind of format. So that's called the standardization. And also the virtual physical integration. So the virtual and physical integration means you can have a virtual one, you can have a really physical one. So you can put, just like when we play the game of Pokemonster. When you play the game of Pokemonster, you are using the virtual one with the physical one. What your camera, what's a recorded video will be able to show where is the surrounding area. And lots of good technology and smartification. So that's the development dimension. So there are lots of application by the smart city already, by this kind of technology. Like in Taiwan, if we see the left-hand side, we'll be able to see this one is a temple. So we can use lots of information to build up the entire temple information as a three-dimensional one. Even in some of the coastline in Taiwan, for every yard, when it goes out or comes in, the camera will be able to identify whose yard it is, what kind of yard it is, and if it's been registered or not. So lots of application has been used. And also in Taiwan, the kind of three-dimensional disaster reduction using a smart cloud system, especially in Taiwan, the government spent the past 20 to 30 years to build the entire 9 million building as a three-dimensional one. So in Taiwan, we can very easily interconnect it, machine to machine, and use different kind of this kind of information to simulate where are those kind of high risk area for floods. And we can use a simulation to simulate if the water gate need to be open or closed, or use lots of this kind of three-dimensional simulation to check about a good land management. So there are lots of different kind of things we'll be able to use, because in Taiwan, the entire nationwide, we have all the building, all the roads, and all the underground facilities has already been in three-dimensional format. So there are lots of these kind of things. And let me emphasize why the Taiwan government tried to do this kind of smart city and also use a very good digital twins information. Because the first thing is for nature disaster prevention, such as this one in Taiwan. As you can see, this is Taiwan, 36,000 kilometers square, this entire size, the mainland China and Japan and Korea. So in Taiwan, there are lots of typhoon invaded Taiwan from all the direction, especially during the summer season, So we suffered by those kind of typhoon. And historically, for each typhoon, it came to Taiwan and stay here or make some kind of disaster in probably 24 hours, that's 1 day, or 48 hours, that's 2 days, or every typhoon lasts for 2 days or 2.5 days. That's it. This is the hour for the duration. And this is a cumulative rainfall for each typhoon. So you can see every typhoon on the average, might bring about 500 millimeter of the rainfall in 1 or 2 days, or 1,000 millimeter of the rainfall in probably 2 to even 2.5 days. One of typhoon, the Herb, in 1996, brought 2,000 millimeter of rainfall in almost 2 days. This one, the black one, the Typhoon Morak in 2009, invaded Taiwan continuously for almost 4 days and get record height of almost 3,000 millimeters. So as you can imagine, 3,000 millimeter, that's above the average of the entire year's rainfall amount pulled down from the sky to some of the village in southern Taiwan continuously for 4 days. So it creates a lot of landslide there. And when the dam bursting, it caused a lot of tragedies. So in Taiwan, each year, there are always different kind of typhoon invaded Taiwan. And we do suffer by typhoon, we do suffer by the floods. So there are floods still every year in Taiwan, in some of, especially for the coastal area. So the government has to spend a lot of energy. And also, if we claim as a smart city, then first we have to say, if we can make a very good disaster prevention, if we cannot stop the typhoon, but at least we can reduce, or that the city has a resilience to cope with the possible damage it may bring by typhoon. Another natural disaster in Taiwan is the earthquake. As you can see in this one. Every year, we have more than 10,000 to 20,000 earthquake events. In year 2020, there has been 23,000 of the earthquake. Of course, some of the earthquake happen in the ocean zone. And some earthquake is, the magnitude is below 3, which means we'll not be able to really feel it. But for people to feel the real earthquake in Taiwan, only average each year is above about 1,000 events. So every year in Taiwan, there are almost 1,000 earthquake events, is higher than Richter scale 3 magnitude, which means people can really feel it. So in Taiwan, we suffer by the natural disaster of typhoon. We suffer by the natural disaster of earthquake. So in Taiwan, what the government has been concerned is the environmental monitoring. So why I'm saying about the wireless communication, why I say about those kind of facility and those kind of sensors are very, very important, because each year we suffer by a typhoon, each year we suffer by earthquake. So we do need a very good technology to make a good pre-warning or make good alerting system. Try to reduce the possible damage or try to avoid any kind of possible damage, especially for those high-risk area. Because most area in Taiwan is very fragile and very, very sensitive. Because we have very, very high amount of rainfall during the typhoon season. If there is no typhoon, we suffer by the drought. And we are very sensitive to any kind of earthquake. So various equipment used to detect and monitor all kinds of environmental characteristics in Taiwan. Lots of. So in Taiwan, we focus on how we can monitor, how we can make a very good integration system, how we can make good interoperability, which means every organization, every university, every governmental or private sector can work together and use good of spatial information, cloud computing, open data, and big data. So that's why in Taiwan, the government tried to establish the kind of national GIS for the past 20 to 30 years. We collect a lot of very detailed information. One of example in Taiwan, the Department of the Soil and Water Conservation Bureau. This bureau has established the kind of monitoring scale on the slopland or high mountain area, which has a very high risk of the landslide or a debris flow. So those kind of sensors has been developed or deployed in many slopeland or high mountain area in Taiwan. As this kind of on-site station, this kind of mobile one, this kind of portable one person can carry, or this kind of self-operation, the rain gauge and also some other sensors together, use different kind of communication scale, and has its own power supply. So all this kind of information provide, all this kind of sensor provide lots of very useful and also which is needed information. Try to have very good disaster prevention and making a good alerting or warning system to anyone who live nearby or anyone who has been suffered by typhoon, by high rainfall, by earthquake. So there are lots of this kind of monitoring station, and all these kind of monitoring systems in Taiwan use a lot of different kind of sensor: the camera, soil moisture, the geophone, the water sensor, the rain gauge. And also there's a monitoring station, there's lots of monitoring station in lots of very high risk area, and mobile station or even portable unit. And all these sensors use different kind of communication. Use 4G or even now it's 5G, NB-IoT, ADSL, LoRa, microwave, or even through communication satellite. Because in most of those rainy days, none of this kind of other transmission is workable because out of power and or the Wi-Fi station is out. The only one can use is use a satellite dish and transmit all information directly to the satellite. Through the satellite, then transmit it back or the information back to emergency operation center. And this kind of center has already deployed a lot of different kind of platform, such as the platform and also the app use the cell phone. So in Taiwan, not only those kind of monitoring station, but this kind of mobile facilities has been developed. There are lots of this kind of vehicle, and the vehicle is four-wheel drive, and you can drive up to those kind of mountain area, high-risk area, and leave the facility on the site without anyone is taking care of that, because its entire area is a high-risk area. No one can stay there. Only this kind of facility, those kind of machine, and the facility equipped with satellite dish to have satellite communication, equipped with all the camera, the rain gauge, and different kind of communication. In case of one communication is out, and it equipped with the self-powered generator. So there are lots of different kind of things. Can provide the power, can provide the communication, and that the sensor be alive. So the sensor will be able to transmit it back all the information when it's needed. But we cannot build all the permanent station or have this kind of mobile. It's pretty expensive. So we also developed the kind of portable unit. Have anyone can just easily carry this kind of portable unit up to the mountainside, and the unit itself has soil moisture, has a power supply, has a rain gauge, a data checking, and also the solar panel to receive the solar power for recharge to the battery. So it can survive, it can live by itself, just live on the field. So in Taiwan, whenever it's needed, the vehicle can park in any kind of safe place, and we can have people to to carry this kind of portable unit and to any places with a high risk one, have the facility just live on the ground. It has rain gauge, it has camera, it has lots of information. And we can check either through the PC, through the browser, or even use our cell phone. I can check directly what the camera is looking at. If there are any kind of landslide, if the rainfall amount has exceeded certain threshold. And I can identify if I need information for this one or that one, or this information for this sensor or that sensor. So I can very easily retrieve or easily analyze all the information I needed without anyone stay on the ground. There's only facility over there. There's only some of the sensors over there. So that make it the kind of device communicate with each other, and also can transmit it back. So in Taiwan, those high risk debris flow area or high risk floods, rivers, it's all equipped with camera, with the water level meter, with a rain gauge, wire server, geophone, and lots of other things. And there's already some kind of web-based decision support system. You can easily browse the fema.swcb.gov.tw, and you can very easily to get information for the entire different high-risk area during the typhoon season. And it can have real-time rainfall data sources, because all this kind of rainfall rain gauge, it can transmit it back. For every 10 minutes, I know exactly what the rainfall amount, the cumulative amount is. So it's an auto one. It's on-site monitoring station, disaster-resistant communities. And also, on the same time, I can receive lots of other information from other agencies, like the Weather Bureau agency. I can receive the QFP from Weather Bureaus, from Central Weather Bureau, or even some other international organization like NOAA. They also have good weather satellite. So we can receive all information, and we can receive on-site information, make a good debris flow warning announcement. So in Taiwan, all this kind of equipment has already been put on those high-risk area of the landslide or debris flow high-risk area in a mountain area or a slopland. So there are lots of these kind of sensors. There are mobile station, there are permanent station. There are lots of these kinds use the satellite communication or fiber or microwave or 5G, 4G, LoRa or NB-IoT. All information 24-hour give to the emergency operating center, because the center, all the people here, they need the information directly from the field. And also it can announce the alerts, because it can work together with some other bureau, with some other organization, and check it about the entire Taiwan's information, or even the world, and provide good monitoring website, or provide some kind of warning system to the local village people. So there's lots of information. And also those kind of warning system, we can use a very easy, simple one. Red means something happened. Yellow means you have to be careful. Blue or green means nothing happened yet, but you have to be watch out. Let me express one of example. So in Taiwan, lots of this kind of high risk area, slopland or the wild creek, has already equipped with lots of different kind of sensors. And all those sensors can stay on the ground by itself, because those places is always in a high mountain area or hard to reach slopeland. So those kind of station and equipped with all the kind of sensors, all different kind of sensors. And as you can see, this one, this is the information we receive by the geophone. The geophone has been embedded in the upstream. It's about 20 kilometers away from where the camera is. The camera is located at the middle stream. So on the upstream, in the very early morning, like 20 minutes before, before it's almost 7 o'clock, like around like 6:30, we received a very high signal, a very high energy by the geophone at the upstream by the X and Y, Z. So we know on the upstream, there has been landslide, very serious one. And 20 minutes later, on the midstream, the camera captured one event of the debris flow. This is how we call it debris flow. Especially during the typhoon season or the high accumulative rainfall amount period, it's very possible to have this kind of very, very serious and very dangerous debris flow happen. And from the website, we recorded about 30 to 40 different debris flow events for the past 10 years in Taiwan. The reason for us will be able to get all information because we already put lots of these kind of sensors in the upstream, in the midstream. So it records the entire camera, and also we know exactly the velocity, the volume, the amount, the density. Lots of information, lots of sensors over here. So we learn about the mechanism of this event. And lots of university scholars, professors, been work together. Like we try to have a good early warning. Like now we are sending those kind of alerting or warning system by the rainfall amount prediction. But in the future, we should be able to use some other factors together because we are learning each year because of those kind of nature disaster are still happening in Taiwan during the summer season, during the typhoon season. It happened, it still happened. So we learn by each time and we collect all the information and we can analyze that. So that is one good thing for the disaster prevention. So in Taiwan, there are lots of young people graduate from the university, got their bachelor or master or even PhD degree. And there are lots of students, they emphasize on one of the AI strategies. So in Taiwan, even the government promotes the AI education. There are lots of universities provide different kind of AI courses. Even the Taiwan Space Union, like this one, are free providing the online course of the GIS and also some other space issues courses free online to all students in the world or anyone who is interested in this field. So the AI solution now in Taiwan is a demand-driven. There are lots of AI techniques needed, like this one. If we use only one camera to look at the entire Wild Creek, if nothing happened, there's a very, very stable flow, then it's green light. Already something happened, there are turbulence or there's some kind of things, then that's the yellow. If really happened, then goes to the red. But this is only one sensor. The entire system have to make sure this is not only one sensor malfunction. If there's something, if there's a nail crawling over the camera, it might say there is a debris flow. So the sensor has to double check. It can check with the other sensor, the rain gauge, the velocity, the water level. Make sure it's not only a camera malfunction because it's sending the alert directly. So when something happened, the entire system knows, okay, this is the area you have to be look at. You have to be carefully look at. Now something happened. Now this is real happen. And also double check with the other sensor, make sure it's not only one sensor's malfunction. So this is what we say AI means. This sensor talk to this one talk to this one, this one talk to this one, this one talk to this one, and mutually They talk to each other. So that's we say sensor to sensor or machine to machine. They can communicate. And the reason for that, so I think the previous one demonstrates how the Department of Soil Water Conservation Bureau has been used this kind of sensors in the very high risk area and make a very good disaster early alert or early warning system, because there's an integration system, there's an integrated system, interoperability, and all the sensors can connect with each sensors. And you're looking at this camera this camera reflects the different kind of different watercolors by the spatial watercolor by the wheel. And through the camera itself, it can identify what's the thrust depth, like 11 centimeter or 12 centimeter or 13 centimeter. So because of the different vehicle has the tires, so the wheel went through the thrust area and has different splash of water. So the color means the thrust depth. So that's the AI. Because the thrust detection by the camera itself, it can tell what's the thrust size and also the depth. Like this one, it can automatically identify the boundary of the thrust, because the entire thrust is a kind of moving one. So the boundary is changing. So the kind of flood recognition technique use lots of learning scale by the edge computing. So each camera is a smart camera. It can learn by itself. It can learn by itself. So all this kind of camera, it can learn by itself, saying, okay, this is the flood area, and the size of the area, and also the depth of the area. And you can make directly a report, use a line notify. So there are lots of information can be very easily used. You don't need to put a person to look at the entire system, but you can just use the smart CCTV to make any alert. So the floods detection dashboard has been developed in Taiwan in lots of different cities. Well, because we are keen to the kind of nature disaster, the high rainfall amount, the typhoon, the earthquake. So all the city government, they really need a good system, a good platform for the disaster prevention and even for a disaster report. But if we look at this camera, although it can automatically identify the boundary and also the depth, but only those people know exactly where it is. So nowadays, we can put the entire camera information directly into the Google Earth. Just like this one. So on the Google Earth, you'll be able to identify this camera, the boundary of the floods represent here. So it changes with the boundary changes. So you know exactly where this is, you know exactly. The reason for that is because the camera, all information can be automatically transmitted directly to the Google Earth because it's all receiving and sending the same kind of format, the standardized information. So that's what I mean. The standardization is one of the very important issue as the smart city. Okay, so I mentioned about those kind of sensors. I mentioned about some of the nature disaster in Taiwan, how we use the kind of sensors for early warning, for disaster prevention. So that's some of the example application that I tried to explain to you how we can use that. So let's take about a 10 minutes break. And then 10 minutes later, please come back and we'll talk about the next 50 minutes, the GIS course online. So this is Taiwan Space Union, and we're offering the free online GIS course in this 2 months, every Wednesday afternoon from 2 to 4 p.m. in Taiwan time. So let's take a 10 minutes break. So let's be back in 10 minutes. Thank you. Hi there. My name is Tien-Yin Chou. I'm the director and professor of the GIS Research Center in the Fengyang University from Taiwan. On behalf of Taiwan Space Union, we are offering the GIS online course. And this is the second lecture and on the second session. So I just previously explained how Taiwan government and how some of the city has been used different kind of sensors to reflect all the real-time information and also have very good system and also can interoperability, can communicate with other sensors and mutually build up a good integrated system for disaster early warning or disaster prevention system, because we suffer by nature disasters such as typhoon, such as earthquake. So most of city is smart enough to reflect all information. So now let's go to the second session of this afternoon lecture. So let's talk about some of the challenges, especially to agriculture, because agriculture in Taiwan is also one of the very important factors. Even though we have only 1/4 of land are flatland, and also we have only about 1 to 2% of the entire Taiwan's area can be used as agriculture land use. But still, we're still suffering by the worse environment, the depletion of natural resources, and also the population growth with the food shortages problem. Because we change our eating habit. We're changing a lot of things now. And so in Taiwan, the agriculture is also suffered by lots of different issues. So unable to provide some kind of sustainable environment, we need a lot of things. Data analysis achieve the balance between environment conservation and industrial development, because in Taiwan, the entire economic growth still depends very high on the GDP growth. They use green technology to monitor and manage the economy, environment, and energy. So now everyone is talking about SDGs, everyone is talking about ESG. So all the world is talking about the zero net emission in the 2050. And able to reach that goal, we also need a very good way for our agricultural production. So many years ago, the machinery development used lots of different kind of tractor and lots of different kind of very good facility. And then the fertilizer, then the biotechnology, and also the data sciences. Now, even for the agriculture, it's also toward to a digital twin. So I was talking about the digital twin, how we can make a virtual and physical one, and for nature disaster prevention. Now I'm going to talk about agriculture field, how we can also make a digital twins of the agriculture production. For example, a digital twin for the agriculture is a virtual model of the processed product or services. Like, this is the corn or the maize. And this is, if we can simulate the entire growth, either use different kind of sensors or even use a simulation model. So if we can know exactly the growing process, the harvesting, everything, the soil, everything, then we'll be able to make a digital twins of the entire agricultural productivities. The linking the synthetic biology, sensor system approach, communication sciences for the next agricultural revolution. So this is the approach in the world we would like to reach. So there are lots of scientists, there are lots of researchers. They try to simulate different kind of major crop. They try to use some kind of physical model, not the empirical model, but physical model, to really simulate the species of the crop, how it grows, for the stem, for the root, and the water goes into the root or the water stay in the stem, and how the entire things have been changed because change of the carbon, of the energy, and also how the plant grows until it mature and can be harvested. Even for the rainfall amount, the fertilizer amount, the infiltration, the root development, or nitrogen, or even a nitrate leaching problem. Or it goes to the underground water. So the entire grain for the entire biomass, there are lots of different kinds of physical model can simulate because of the temperature and the radiation, and also the carbon dioxide, the photosynthesis. And this is entire circulation. And also the canopy development. And also some of the runoff might induce because of the agricultural productivities. So it's a kind of circulation. And there are lots of different kind of physical models to simulate the entire crop growth. So it can very detailed to simulate, like in the world, there is a series model, or people call it DSET model, or there has been some new updated model, like some model from Dutch, or one model from Michigan State University, the Salus model. There are lots of different kind of physical model can describe very detailed how each different kind of major crop, like the rice, the wheat, the corn, the soybean, the tomato, can grow in the field, really simulates the entire growth process. The way why it need to be simulated, because it concerned about the carbon dioxide, which is the major factor of the greenhouse effect. And also about the radiation, the energy from the sun, the wind, the gravity, the everything. So there are lots of the water, the fertilizer. So it can reduce the fertilizer being used. It can make a very precision agriculture, or very, very precise calculation of the correct fertilizer in the right time, or the correct irrigation amount in the right time. So it can reduce the waste. So in the world, there are lots of scientists, there are lots of researchers try to make this kind of crowd-based analytics. Use different sensors in the kind of agricultural productivity land zone, use the drone, use everything to detect lots of things, to get receiving lots of the radiation, the temperature, the humidity, and the stress of the plant, lots of. Use this kind of information, we'll be able to identify for each agricultural productivity, the land zone. Which land zone area, which area is high sensible, which area is under some kind of depress, the water shortage or the fertilizer shortage. So there are lots of different kind of physical model like this one. This is called the Salus model, being developed by the Michigan State University. And the previous version is the DSET model. So this kind of model, it can retrieve the weather information, management information, and biotech interaction. Everything. It can really simulate the crop growth, the roots growth, and simulate the yield, and the flux, the drainage, the runoff. So all this we can count as socioeconomic, because it can sell on the market. All this is concerned about the environment, because the nitrogen problem, because of the runoff problem, because of the carbon dioxide. Everything, because the management can talk about the planting, the residue, the tillage way, the fertilizer amount, the manure, the pesticide, the irrigation, the drainage. Lots of this kind of management issue, weather issue, and the biotech interactions can be input into the model and can simulate the entire output daily. So use this kind of model, physical model in the world. It can represent for each different kind of crop farm the performance of the land, and can use a very simple estimation to estimate the entire output of this farm, and also if the yield will increase compared with last year, because it can identify about the current situation of the crop. So use this kind of model, use this kind of sensors technology in the world. It's possible to make a sustainable agriculture system. It can reflect the value. Because it's not only the yield, not only the productivity, not only the sale in the market, but it's also count about the greenhouse gas emission. It count the nitrogen leaching to the underground. So the entire model can really reflect And also use some of the sensors, will be able to make validation and to create the correct simulation of the entire crop growth. So use this kind of tools and facilities and sensors and model. That's what I mean by use GIS, use remote sensed images, use drone, use sensors. We'll be able to do lots of things, not only the agriculture, for the forest management, the ecological investment, the ocean conservation. Taiwan is an island. So constantly, we need to identify about the ocean conservation. Lots of information will be able to use the GIS, use the remote sensing, use the drone technique to reflect. Even for the sea animals care and management in lots of different kind of research. As this one is showing you how the drone can carry some of the tree seeds, make as a granule. Inside, there's some soil, some clay, and some fertilizer with some of the tree seeds. Make a granule one and use the drone to deploy in some of the places is hard to reach by any human being. So use the drone to spread out the tree seeds in the slopeland. This is one of the very good usage. And also we can use the technique to observe the outcome in the 2019, 2020, 2021. The green coverage reached about 57%. So it worked very good in this slopeland because this kind of slopeland is hard to reach. So we can use the UAV, carry this kind of gravel and have it deploy all the seeds in the high mountainside, the slopeland, and produce a very good result. So this is also one of the very good use combined with the drones with some other technique. And also in Taiwan, lots of the different cities, if we say smart city, one of the hard one to reach is agriculture part. But some of the city emphasize on the agriculture. So even for the agriculture, we can also use the same kind of technology as agriculture monitoring decision support using Internet of Things. Not only for the disaster prevention, but also for agriculture. Such as agriculture, the hazard warning, like if there are high temperature, if there are drought problem, if there are floods problem. So there are lots of different kind of warning, or even there's air pollution, or the PM 2.5, PM 10, or the farmland management, like how to use this one to overlay with all the other maps together or monitoring. We can put a lot of sensors around agriculture land. So we can create a kind of smart agriculture. So like agriculture before, we can only check about a two-dimensional map, but now we can use also the three-dimensional display of agriculture information, which is easily to create good environment and farming situation, and also if there's floods. So there are lots of things we will be able to use different kind of technology. So in the first step is to collect and establish of the farming, crop yield, and policy information. So we need to do a lot of field investigation for the data collection, use remote sensing, interpretation. So lots of information, lots of satellite image, drone images we'll be able to use also to build a very good agriculture information. So in Taiwan, even for the agriculture, the central government has built for the entire farming area for each farm, which crop and who is the farmer, and in the size and what kind of crop, what kind of vegetable, what kind of fruit, and all the information has been receiving and constantly updating. Because we need this kind of information as a basic information. So all the data integration and publishing, we can automatically use some kind of checking mechanisms. So all the farmland we can identify into each small farmland parcel in Taiwan. Most of farming is a very small one. We have only about 0.25 hectares for each farmer. So each farmer owns a very, very small farm. So in Taiwan, most is small farm farmers. So use these kind of things, we'll be able to use the GIS to collect all the data and also to make correction and annual report and make some good statistics. And lots of information has been collected. Lots of the farmland, for example, like in Taiwan, the paddy rice. The paddy rice map. Each year, the central government used the aerial photo to identify the paddy rice map, because paddy rice is one of the basic agriculture crop, a very important one in Taiwan. So the government need to ensure about the paddy rice productivity each year. And also because we suffer by the typhoon, suffer by the earthquake, suffer by some other nature disaster. So the government is paying high attention on those paddy rice productivity. So there are lots of good information has been collected over the past 20 to 30 years. And it's a large database for each paddy rice farmland. All this kind of information we'll be able to collect, even for the yield, even for the farmer, even for lots of things. And the pesticide use, the fertilizer use, and lots of information. And the rainfall amount, the irrigation amount, everything, and the yield. So we have a large database. And even for the crop rotation, and also the fallow. So this database with the GIS files together in Taiwan has been built for the past 20 years. So the government knows exactly for each rice farmland or even other kind of agriculture farmland who has been used, which area of the farmland, and produce what kind of things. And also use the mobile. The government trained hundreds of volunteers to go to the field site to check if this rice paddy farmland is correctly produced a rice farm still. So there are lots of like this kind of cell phone and be easily used and identified as a proof to get a photo. So there are lots of this information has been built up for the entire Taiwan. For different year, we know exactly who is growing what kind of fruit, what kind of, or even paddy rice, or what kind of things in each county or each city. So this is the way to make a city a smart one, because the city mayor, the decision-making person, or the Bureau of the Agriculture know exactly who is farming what kind of crop or agricultural productivity now and for the past 10 years. So we know exactly lots of information directly, and also not only the agriculture information, but also lots of other information from other agencies. The reason can able for all this kind of agency or bureau can talk to each other, because everyone uses the same kind of standards. Everyone uses the same kind of maps format. So we can easily exchange directly. Okay, machine to machine, or even sensor to sensor. So that's easy to change all these kind of things. So it's very easy to inquiry for historical information or even the air photo, the historical list, everything. So in Taiwan, lots of city has adopted some kind of supporting system to make a good informative agriculture industry. GIS has been used to the agriculture is one of the major goals for lots of cities, because always the agriculture technology, if compared with industrial technology, is sometimes it's a kind of behind. But in Taiwan, the government still focus on agriculture one, because we try to make smart agriculture is also part of the smart city. So use the GIS, use this kind of graph and diagram, we'll be able to visualize all the dynamic dashboard for the sales or the price analysis, because the farmer needs to know what I need to plan for next year. Or if there will be a good market price after 1 month, because I can harvest those tomatoes after 1 month. So there are lots of daily trend in a crop price, and also the prediction, and also the historical information. So provide the farmer, provide decision-making person knows about the local market, knows about the nationwide market, and just use a dashboard. There are lots of things we'll be able to use, like even for the early warning module. Like if there will be high temperature, or there will be a very drought one, or prediction for the next 7 days, the temperature will be higher than 30 degrees. So these are some of the crop you have to be pay attention to, because those crops are very sensible to high temperature. And it informs you, you can ask who and what kind of information you might need and what kind of prevention strategy you should adopt. So use all these kind of things, the farmers or the Department of Agriculture in the city government can very easily to identify lots of things. The weather warning, because all the information can receive from the Central Weather Bureau, and also from historical information, and also from the current information, who is the farmer are, what kind of crop is growing. And for the system itself, you can receive lots of different kind of information directly from the other information being organized, like the satellite information, like the weather information, lots of things. So you can know about the air pollution possible. You can know about the humidity possible. You can know about the temperature. You can know about lots of things. So you can plan ahead. Build lots of this kind of information, the heat, the cold, lots of the drought, lots of this kind of information. So in Taiwan, lots of cities try to develop some kind of cross-management simulation. Just use the different kind of simulation, and like this one. This is in the southern part of Taiwan, the Kaohsiung city. The city government adopted already 35 types of the main crops. So for those 35 types of the main crops for each farmland, there's a GIS for agriculture management, because know exactly who owns which farm lot and manage for what one. So the layer, everything, and also can use a very simple one, just use a cell phone. And the farmer can report about the current productivity, even now, even the possible web to sell the fruit. So there are lots of information you'll be able to receive through this platform. So the agriculture field surveying system. Also, there's a three-dimensional one, because in Taiwan, we have very detailed digital terrain model, or digital service model, or digital elevation model, very detailed one. Very detailed one. So we can use a three-dimensional one to show on like the farmland, like in Taiwan, not only the flatland, but also some slopeland has a tea plantation. Some slopeland has some kind of fruit plantation, which produce a very good, very high economic return. So those kind of dashboard, not only for the natural disaster, but also for good agricultural productivity. So lots of statistics will be able to showing on the farmland. So there are a lot of things will be able to show, like this one. In each farmland, we can use a LiDAR to provide very precise information. Like in the central, there's a farmhouse, and also the other places, there are irrigation equipment, and it's different kind of productivity. So based on this, we'll be able to embed it with some of the GIS data sets and some other good historical information. Then we'll be able to do a lot of simulation, a lot of prediction, a lot of things. Use this kind of sensors, use this kind of wireless technology. There are lots of information we'll be able to get through this kind of technologies. So this is very useful in Taiwan, as I mentioned about, because Taiwan is a small island with 23 million people live here. And most of us stay on the flat land, only 1/4 of the entire Taiwan national land. Most of people stay there. So there are lots of very populated cities. So that's why each city try to make a city as a smart city. And able to make a smart city, you have to have a good information data sets, enable you to get the analysis, enable you to get the prediction. And if you have a good research or model, then you can predict, you can simulate, you can assess everything in advance. And also use different kind of sensor, you can get all the current information directly from the field. Not only disaster, but agriculture, but every kind of land use. All this kind of information, you'll be able to get all the information directly. So getting all the information, you'll be able to catch a good database and use the database, you'll be able to provide a good strategies. So that's how we say a smart city. That's how we say a smart city. So nowadays, the GIS, we can compose with a 3-dimensional model very easily, because in Taiwan, there are 9 million of the buildings, and all those 9 million buildings has already created the 3-dimensional building model. Some of building is very detailed one, some building is a roughly one, the level of detail, different kind of level of detail. But we can receive all information directly through different kind of governmental agencies directly. I can use this machine communicate with the other machine, either from the public or from the private sectors. So use this kind of technique, we'll be able to produce a digital twins of this entire city. As you can see from the screen now, this is one of the city. And also if we try to go into a building, we can also integrate with the BIM model, the building information model. So every model will be able to merge together and use the same kind of platform to make a good display, make good analysis and calculation or prediction, and combine with some kind of model, we'll be able to do a lot of things. We'll be able to do a lot of things. So let me show to you one of the video by one of the city in Taiwan, the Taoyuan city. Several years ago, the Taoyuan city won the world champion by the ICF as a world champion smart city. There are several reasons of that, because the Taoyuan city is equipped with lots of sensors already, and the entire city has been highly developed as a wireless city, and it has an international airport. It has a very good facility inside, but the basic infrastructure of the entire city is pretty good one. So that's why the Taoyuan city has won the champion of the smart city several years ago by the ICF community. And this is one of this is one of the video we made for the Taoyuan city to show how smart it is. So it composed with a lot of information I just mentioned to you in the past, in this afternoon, about how we can integrate with all the sensors, how we can integrate with all the platform, with all the models, and toward lots of things. Not only the infrastructure, but the communication and the transportation and the health, lots of things. So let me show to you. I'm sorry. This is one of the things I just mentioned to you, the wireless communication inside the city. So this is one of very good infrastructure for any city to crank or to become a smart city, because you need every sensors enabled to communicate with each sensor through different kind of communication. Either SIM card, use the 3G, 4G, 5G, or in the future the 6G, or the satellite, or the microwave, or the LoRa, or the NB-IoT, or cable, or Wi-Fi. So use this kind of broadband and lots of information, like in Taoyuan, there are free Wi-Fi provided by the city government itself in most of the part in the city. As you can see, like in this film, we use a lot of this kind of three-dimensional things. Some of this is by some different architecture. You SketchUp or some other model and create this one. But we have to use, and also to integrate with aerial photo, with satellite image together. The NB-IoT is created by some of telecommunication company, and it provides a very cheap and very stable signal at very, very low cost. But of course, because it's cheap and very reliable, so the volume of the information inside is not that large. So if some of the signal just need to transmit it back, like one or two signal, like in 1 second, every second, not the image one, then we can consider to use LoRa or NB-IoT. This is system. These are the system I just showed to you on my speech, like how the Taiwan city government can use the different kind of GIS platform, and also with lots of sensors to identify lots of information. And all the sensors are being built by different departments inside the city government. Some is by the Department of Police, Department of Traffic, different department. This is what I mentioned about enable to create a sustainable environment or sustainable things. We need the sensors, and we need the very good, like the green technologies. Like in Taiwan, a lot of industrial companies produce different kind of green technologies, like the reusable water or the treatment of the wastewater. Lots of things, or even for the garbage waste, like how we can treat the garbage waste into a useful packages things. So all those things, it create a sustainable environment and fit the goal of the SDGs and reach the ESG requirement. This is what I mentioned about how you can use the aerial photo. I can use the GIS, the three-dimensional building, and how you can interact with all the information and to make a very good three-dimensional display. You see, this is the goal of the smart city, to have a very smiling citizen, even for the kids. So that's the final goal of the smart city, and that's why all the city who claim as a smart one need to use a lot of like GIS, a lot of remote sensing, a lot of this kind of location-based information, and to get a better environment and to prevent the disaster prevention and to make a disaster resilient city, and also to create good innovation, how we can use those kind of data. So you can have a good data sets, open data strategies. Like the one in Taiwan, we have nationwide GIS strategies being developed for the past 20 to 30 years. And for lots of different cities in Taiwan, they have also promote their own open data strategies. So that enable lots of small and medium enterprise to be promoted, and how can use those kinds of good information to prevent even better life. So I think that's the final goal of the smart city. And that's why the smart city uses a digital twin and provided by the good GIS technology, the AI technology, IoT, and it's possible to reach the final goal. Okay, so I think this concludes my this afternoon talk about smart city toward digital twins and in the GIS online course. So this is Tien-Yin Chou, the director and professor in the GIS Research Center in the Fengyang University, on behalf of the Taiwan Space Union. And thank you for your listening, for your participant. And there's still 4 courses is coming, like next Wednesday. I'll talk about some transportation and logistic uses. And after that, some of my colleagues will talk about the drones. My colleagues will talk about some other usage as how we can use the GIS, how we can use the remote sensing images, how we can use the drone information to create a better life. So that's best wish for all of you to join this online course. So let me get it back to the course organizer.
Thank you very much, Professor Zhou, for your wonderful course. Thank you.
Okay, thank you.
Thank you. That's the end of today's course. Please fill the Google form and the 2 quizzes. If you have any questions, you can leave it in the Google form or email it to me. I will pass your questions to Professor Zhou. Thank you all of your participation. See you next Wednesday.